Good morning, and thank you for attending this webinar. One of the questions I get asked many times is, why does IRISS have a different type of infrared window to everything else that's on the market space? So I've decided to do this short webinar to explain really how our systems have evolved over the years and why our designs are the way they are. So looking at infrared windows, one of the things we first have to realize is that infrared cameras can only measure the temperature of the objects that they can physically see. So they can't see through solid objects, they have to physically see what they need to measure. Therefore, an infrared window has to be designed so that infrared cameras can see all the components or connections within the electrical equipment, but with the covers and doors in place in what NFPA classes as a fixed and guarded condition. Now, because you can see through something, so let's say the plexiglass or Lexan that's in electrical switchgear that you use every day for visual inspections or for lockout, tagout, etc. Those are totally solid to an infrared camera. I mean, an infrared camera just can't see through them. It's like you trying to look through a solid brick wall. So therefore, we need to find special materials that allow infrared energy to transmit through, so that the infrared camera can make its measurement. So there are there are a gazillion types of lenses out there that are infrared transmissive, but the most common types, because of their stability and cost, are the transmissive polymers, which is IRISS's specialty, and we were the first people to develop those and bring them to the market space, as well as the traditional fluoride-based crystalline materials that you see in place today. So if we look at, this is a BPFC, so this is basically a legacy product that uses calcium fluoride or a fluoride-based crystal lens material. When we look at these materials, this window had a stainless steel cover, an IP67 insulated plastic housing, the infrared viewing window itself. You could do visual inspections through them. You could also do ultraviolet inspections through them, but there are problems with these. They're fragile, so they're non-impact resistant. Not IP2X fail-safe. If you break the crystal, in this case this is a 4-inch diameter window, you end up with a 4-inch hole. And they have a limited lifetime warranty, and they're hygroscopic, so over time they will absorb moisture from the atmosphere, which basically affects the transmission of the infrared energy, which can cause you real problems in temperature measurement. So we want to keep the good things about this lens, but the thing is we want to get rid of these mechanical failures, because these are the problems that we see in the field every day. So IRISS, we looked at the failure modes in the legacy type crystal windows, and these are traditionally caused by impact through direct or indirect impact. And by indirect impact, I mean that even hitting a cabinet near a window, these shock waves can shatter crystals, and we see this happening all the time. Load applied to the lens system tends to break them, so they're not, they can't take any sort of load or impact. Heat damage is another area where we see them get damaged, and also the primary one is the hygroscopic failure due to moisture ingress. That's the biggie. So when we looked at these, we wanted to design a lens system that would enable us to get around these. So our first foray into the polymer materials was the VPFR opaque polymer systems. Now, our original ones had insulated plastic covers. They were IP65 housings. They had the infrared window view transmission was excellent, but the problem is they had no visual capability or no ultraviolet viewing capability, because the polymer was opaque and blocked the transmission of ultraviolet in these units. But the good thing was we actually managed to get an impact and load resistant design, which was important. They had an IP2X electrical fail-safe. That means if you ever damage this lens, the largest hole size is less than ½ an inch, so you can't get your finger in there or anything else. They can now have an unconditional lifetime warranty, and they're made from insoluble materials. So we now found a way to design out all of those mechanical failures of the traditional legacy products, but we did have a problem still that we had no visual capability or ultraviolet capability. So we did make a version that had a plexiglass window in there, but we spent a number of years developing a clear polymer that we could actually do all of these from. So that was the VPT infrared window system. So the VPT is a clear polymer, and because it's clear, obviously now we can do the visual and ultraviolet and infrared all through the same unit, and we still have all of the benefits of the mechanical stability of this lens design. So that's why IRISS went through that design system to actually try and get rid of all of the failure mechanisms of the current legacy products that you see in the field today. So, just how does that lens look? So this is a brief experiment we've done showing a crystal versus an opaque and clear polymer window. So we used a FLIR E60 camera, 320 by 240, a standard infrared camera, 10 inches away from a heat source. We put ID label, an emissivity label on there to get rid of reflection. We set the emissivity to 0.95. Now, one of the things I want you to look at when you watch this video is what the writing that's on there, the see what you've been missing writing is clear with all types of lenses. So when you hear people say, oh, you can't see, the clarity of the image is poor and everything else, poor clarity of images is typically down to the type of camera you're using. So whilst you watch this video, be mindful of the clarity of the writing on the target source. Okay, so experiment is, if you look at the lens, we put a crystal in front of there. Look at the temperature, it goes from to 91 from 120 degrees. That's the transmission losses. Then we take the polymer, opaque polymer, and we put that in front of there. It goes to about 97. Then we take the clear polymer window and temperature goes to 97.3. So looking at the results of that experiment, with a base temperature of 119 degrees Fahrenheit, which was the average of between 119 and 120, it was bouncing around there. We've seen the calcium fluoride window show a temperature drop to 91 degrees, which is approximately a 33% loss. We then seen the opaque polymer, the original polymer used by IRISS, drop to about 96.8 degrees, which is a 23% loss, and then the clear polymer to about 97.3, slightly better, but 22% loss. Now, again, really it doesn't matter if it's a 33% loss or a 22% loss. What matters is it doesn't change, and that's the benefit of the polymers, is they do not change because they're non-hygroscopic. Yeah, so that's the important thing to take away from this. So, why just stop at infrared inspections? If you're in the maintenance field, you do a lot more than just infrared. There are many types of inspections that are carried out on electrical switchgear on a daily basis: airborne ultrasound, motor current analysis, partial discharge testing, coronary inspections using UV cameras, as well as airborne ultrasound, power quality monitoring, and the most important, the visual inspection. So therefore, shouldn't we start to think about a maintenance inspection window, not just the infrared window, because that's really not just it's a fraction of what it can be used for. So your maintenance inspection windows or maintenance inspection systems should be considered to cover all the technologies that you are currently using and actually may intend to use. So always think about that when you're looking at sort of getting into utilizing this type of methodology. Yeah, significant investment when you put one of these windows in, or one of these inspection systems in. So you really want it to last, and you want to make sure that it covers all the disciplines. By limiting the scope of the device, you're really not maximizing your return on investment, and you really don't want to limit its future use. So again, maintenance inspection windows or maintenance inspection systems should allow all inspections to be completed by all of the equipment that you intend to use in a closed panel energized inspection of your electrical system. Now the question is, who says infrared windows have to be round? Traditionally, windows have always been round because of the way we were using fluoride crystals, which are grown and much like camera lenses, are much easier to cut and grind round. So when we designed and patented our lens systems, we really weren't coupled or cobbled by the legacy type systems. Yeah, you want to make crystal windows that become very expensive very quickly. So when we started to look at these, we started to think, we could do something else. So when you look at this panel here, you can see it has 12 4-inch crystal infrared windows. Yeah, non-impact resistant, mechanically inferior designs. Again, very expensive. There's 12 installations and 12 units. So IRISS really were the first people to format what we call large format rectangular or square windows. These have all of the benefits of the lens systems that we designed for the VP series, the round windows. But now we started to make these much heavier duty. The window that's in this picture here, this system is a CAP EMV system, 100% stainless steel, arc containment tested to IEC 62271-200, the first product to ever get through that. Very, very tough test for metal clad. And also, we started to make these in standard sizes of 4, 6, 12 and 24 inches wide. So you have a very large format window with all of the benefits of utilizing the VP lens system. So when you compare that to this installation, here we have one custom CAP series window on the top, which went over the visual viewing pane. So you can still do your lockout, tag out, but you're not cutting, you're just drilling the fixing points and it goes straight over the hole that's there. And then the lower window is a CAP CT24 series standard window that really did the job of what those 6 windows, but does it a lot better. So here we go, one custom, one standard IR window, 2 window installation costs, fully impact resistant and mechanically superior design. So again, now when we start using the large format windows, this is why IRISS started to do what we did, because it made sense. I would sit in front of rooms of design engineers and say to them, why do you have large rectangular windows in your switchgear, like the image to the left there? It's for doing lockout, tag out and visual inspection. So they need large windows. They want to put a lamp or a torch in there so they can see what they need to see. So why shouldn't your infrared windows or your maintenance inspection systems be any different? So as our windows evolved, we started to come up with more systems. So now we have a eCentry Connect smart tagging system, fitted to every CAP and custom unit that leaves here. Now this is an NFC tagging system, okay, standalone. There's a free app available from IRISS, and this enables you to save and record inspection details on the actual inspection system for the engineers to use at any time that need to gather that information. As a thermographer in the field, many times we just don't have the information that we need. But with these tagging systems on, now when whoever's in front of there can open that tag, read the information of the last inspection, read the critical temperatures, etc., etc. All of this is on that tag. Also, there's a cloud-based subscription that goes with that, but it's free to use in a local thing. But if you want to back it up and use all of the bells and whistles of the eCentry Connect system, then there's a cloud-based backup, and there's more information available on our website about that. So again, what we then decided was, from a condition monitoring, we see a lot of our customers doing ultrasound and partial discharge testing on their electrical systems. So we decided to add an ultrasound port or a partial discharge port to the units. Very simple for us to do. Then another thing that we evolved away from was enhanced body designs. We made smaller grill systems for customers that had connections closer. They didn't like the IP2X compliant. They wanted a smaller 5mm grill, so we made smaller grills to enable them to do that. Also, we had customers that wanted enhanced maintenance, so we put a removable front fixing grill. And this is in this CAP PD unit here, this is our enhanced maintenance system. Once this system's installed, you can maintain this with never having to shut down or remove this product. So it's fully maintainable, from the front. So it never has to be removed. So again, now when you look at it, once you've chosen your maintenance inspection window, complete with your eCentry tagging systems and a number of other devices that are available from IRISS and some other designs that we're going to sort of discuss now. You can add a Delta T alert. This is a B series. This is a wireless battery powered temperature and humidity monitoring system. So again, you haven't got to put any power up to this unit. Delta T alert, nice system. It monitors the internal and external temperatures and the humidity within the electrical system. And it's available in a number of systems. We have the Delta TP series, which is a powered system. We also have a Delta T Alert housings, which is an IP67 housing that you can just put the standard Delta T into, and you can then put that anywhere. The range is about 300 feet between the sensors and the gateway. The gateway has about 300-foot range as well. Uses a Z-Wave technology, and again, this can be added to your inspection system. Okay, and more information is available about these on our website, IRISS.com. The other thing that we've really just launched is a really exciting system called the Sonus Sensor Series. So the Sonus handheld units that we now have built-in embedded systems into our inspection units that you can plug the Sonus into. So here in this video, this is a CT with a PDS system in it. So here you would literally just take a Sonus unit and plug it into the unit, and then you can make your recordings. The system stays enclosed and guarded all times. It's not like we're using the open port. So now I can just plug in, make my recordings, and again, a lot more information available on our website on this. And there's a complete range of EMSD support products for our ultrasound and partial discharge test equipment. So we have the CAT PDS series that's available as a CT or an EMV. We also have the PDS series, and these are just plates that have the sensors embedded in them that you can install these separately of installing an inspection window system as well. We have the CAT CT4 US. This is an infrared ultrasound port combination. We have CAT EMV PDI series, which has a different type of door opening, much larger. Again, these are used not just for ultrasound, they're used for fire extinguishment release and a number of things. The EMV PD series, which we just sort of reviewed, and the VP12 ultrasound port series as well. So there's a whole bunch of electrical maintenance safety devices that support the ultrasound and partial discharge testing market space. The other thing, again, from IRISS is, there's no such thing as a standard infrared job or inspection job, so therefore there should be no such thing as a standard infrared or inspection window. So we look at these now, we build custom solutions. We have on-staff engineers that design and build these custom solutions for our clients. So we can take an existing cover and basically make you a replacement cover that you just bolt in place. The installation times are a fraction of having to cut them in yourself. And when you're trying to do a lot in a very short period of time, having custom covers really does help out. Apart from that, we have a whole bunch of other things. This is a bus bar C cover that we make. We have a whole range of bus bar covers. CAT B series, again, replacement covers. The quick fix systems we have clear Lexan windows that go inside the touch safe barriers that you can infrared through. Remember I said that you can't infrared through plexiglass, so we make plexiglass grills that you can. We also have the quick fit IR series for panel boards. They just replace the breaker covers. We have the CAT PDM series, as well as the CAT F series, which is a curved window for curved surfaces such as motors or isophase bar bus. So again, in summary, our core business at IRISS is the design and manufacture of electrical maintenance safety devices and maintenance inspection windows. And unlike other manufacturers, they're not items on our line card. This is our line card. This is what we do, and we're the best of the world at what we do. In fact, we're unique at what we do. IRISS maintenance inspection windows allow access for all makes and types of condition maintenance equipment. So again, don't listen to nonsense that it doesn't work with this type of camera, it doesn't work with this type of inspection equipment. We can make systems that work with all types of inspection systems. Only IRISS inspection windows have flexible and customizable designs. Our patents enable us to build systems that no one else can. And as I say, it's our team of in-house engineers really are there to help our clients design the products that they need so they get exactly what they want. And IRISS maintenance inspection windows are the most tested and certified products on the market today. Our products meet or exceed the mechanical environmental testing requirements of all OEMs and all relevant certification bodies. I'd like to thank you for taking the time to listen to this webinar. There's a lot more information about the systems that I went over briefly on our website, www.iris.com, or you can reach out to us directly at info@iris.com. Thank you and have a great day.